I'm starting with a basic terrain. It has not been eroded yet. And I'll start by adding a couple layers of noise of varying size and intensity. The smallest size will be set to 100. You can probably see that the best here. I'll only be using rain erosion. For the first one, starting from the default values, I'll save this mask, and this will be the only mask that I save. I'll make sure to set rain amount to auto, and then the erosion type to extra thick. I want a lot of soil to be carried, so I'm setting up the soil capacity. Direction inertia will sort of drive the direction of the flows, and then gravity will be high. Subterranean depth, this will carve more soil out of the terrain. And then I'm going to set the smoothing to maximum. When that's finished, I'll add another round of noise. Again, the size 1 will be strength 100. Then I'll rerun the erosion, rain again. This time I won't be saving the mask, but otherwise all the settings will be the same. Just trying to get a lot of movement. With smoothing set to 100, it also removes a lot of the blockiness that you'll see around the gullies that are being carved by the rain. Smoothing looks fine now, and we can see a bit of the noise coming through on the edges of the mountains. So this last time, we'll add just the size 1 noise set to 100. And we'll do another rain erosion. I'm not going to save the mask this time either. Resetting everything to default, change auto as always. Then I'll want to reduce the effect that this has moving soil, but I'll turn it, the slope down to 0 and gravity down to make sure that it hits everywhere on the map. It's affecting everywhere at once. Now we see noise is isolated to the places that it should be. Where water's traveling, it's sort of removing out the noise, and you've got channels through it. This looks a lot better. So I'm happy with all this. I'm going to use this as the base terrain to blend. And so I'll take a height map of parameters set to 100 and save it out. I'll just use the ridges height map from the last video to blend into this one. I've opened both the height maps in Blender now. Got the ridge height map here and terraces height map that we just saved. So with the top layer, the ridge height, layer that we want to blend into the base, we're going to set this to divide. Then create a layer from visible. And invert it. Doesn't look like it's going to be much of a blend. So let's take a look at if we did things the other way around and blended the base terrain into the ridge. So we'll set ridge back to normal. Move it to the top. And then set the base to divide. Create new from visible. And then invert that. This looks better. So we'll do it that way. So I'll save both of these. This called base into ridges. And ridges into base. Then we'll take these into TerreSculptor. In TerreSculptor, I've loaded up the ridges height map, and now we'll blend in what was going to be the base. So we'll have external file and load the terraces height map. And use the file we just created for the blend. That will be base into ridges. Increase the blend amount to 100. There we go. We'll see the spots where ridges are taking over, coming through pretty cleanly. And here's a good picture of the variety of detail you can get mixed together from different terrains. So I want to create a new level using this height map, but in it I want to have the terrain textures be different, and I want the megatexture to reflect what terrain textures are being applied in Lumberyard. So we're going to use Splatmaps to achieve that, and we'll take a look right now at the Lumberyard documentation regarding Splatmaps. We're on the page. Looks like we'll be requiring 8-bit BMP files. Here's the example of what they're looking at. I'm using sand here as a splat map that they've used along with rock and the vegetation. We'll do something similar, 3 or 4, but this will be key, 8-bit BMP files. TerreSculptor does have a tool for creating splat maps. They're a bit different. They use a 4-channel image, red, green, and blue, to sort out, look at sand, rock, vegetation, and this is automatically generated. We could use this at some point to sort of normalize between 3 different overlapping maps and then converting the channels to 8-bit grayscale to use. But for this example, we'll just do it a different way. We'll go over using the composite weight map generator, which is a powerful tool. This is a lot of the same color mathematics that we've been using for the masks. I know one of the alpha blend files that we use to blend these 2 terrains will work well for the rocky area that came in, and the other will probably work fairly well, at least in part, for the terraces. We also have the two rain masks that came out, and that might help us get towards some of these sandy areas. So I'll try to choose something that maybe highlights the channels or some other item in the map that's not covered by those three. I'm going to take a guess here, but I'll try to use the full tool here. Start with concavity. I have one extractor selected, and now all of these will be the settings for just extractor A. So I'll need to go down to concavity here, take a guess at some values, and if I have it selected and I press build, it'll come up with something. So those didn't work. I'll tweak these really quick and hopefully get something. Okay. So extractor B, I'll just do a altitude. Now it has its own settings. Right here we'll eliminate the high areas with some fall off. Got B selected, I'll hit build. There, that covers something. Now I'll go to combiner A. Here's the amount that it's going to take. So between the two combiners, I could have them at 50% each, or if this one's at 100, this one's at 0. You might have both of them at 100 too. We'll try multiplying these by first and hit build. It's not a whole lot. Okay, that'll be fine. Now we'll use this third extractor. It's something you can add in to the result of combiner A. Change extractor C to slope and just pick low slopes, some fall off. This gives us something. We'll see what we can use it for. So I could do smoothing here. It's not enabled by default. Select the file. Here, BMP indexed 8 is what we're going to need in the end. And you can give it a name. And you do have to append its file type here. So that's enough mass to work with. I'll save a height map. I think I'm going to go for a 1024 map. I'll downscale again. And we'll move into GIMP. I'll start by creating a splat map for a vegetation layer. Here I'll add in the random mask we just created and the rain sediment and rain erosion masks as well as the ridge mask. And I'll add in the sediment mask, changing the color curves to grab more area and subtract out the erosion mask, doing the same. And then finally I'll subtract out the inverted ridge, create new from visible, and save that as the vegetation mask. For next two, I'm going to add an all white layer and subtract everything I've created so far, changing some layers. And this will be for terrace. The next layer will be just the same, except I'm going to subtract everything, and what's left over will go into that layer. That'll be soil. So those two masks completed with the same method. For the fourth mask, I'll just be using the inverted ridge mask. In TerreSculptor, I'll create a couple color sets and make a couple megatextures to bring back into GIMP. There are a lot of options for doing this. One way is I'll just set all of the Splatmaps to subtract mode, and then I'll hide one and bring down the megatexture for that hidden Splatmap and save it as a visible layer. I'll do that for each of those. To mix the four visible layers, one option is to set the top three layers to lighten or luma lighten, and the last one to normal mode. Don't like how there's no color coming through for some of these, so I'll set the very bottom mask to overlay mode and take a look at what some of the original megatextures underneath everything look like. I like this, so I'll create a new layer from visible and do some of the post-processing that I covered in the last video. Now I'll scale the four Splatmaps down to 1024 and export them as 8-bit BMPs. In Lumberyard, I've imported the 1K terrain and refined it terrain texture tiles and imported the megatexture I created. You can see where the terrain was blended in here, some of the noise that's coming through. Next step will be to import the Splatmap. We'll open the terrain editor, terrain texture layers, and create one layer for each of the Splatmaps. You can delete the default layer and I'll assign materials that are available in the dynamic vegetation sample. Now I'll select a layer, hit Assign Splatmap, and choose the 8-bit splat that we created. After that's done, click Import Splatmaps. Close this and regenerate the terrain texture. And let's take a look. Terrain blending going on. Looks pretty good. Here's the sections where the different parts of the terrain were added together. Yeah, that looks pretty good. In the next video, I'll go over authoring dynamic vegetation in Lumberyard with Landscape Canvas. Thanks for watching.